Those determined to change history might try to send a message backwards in time. But to do that, we'd have to send information faster than light, and that's impossible. However, right now an international row is brewing, because this man reckons he can send a signal faster than light into the realm where Einstein said time would run backwards.
This signal is split into, by an electronic mirror here, into two parts. So we can compare the signal. One is moving through the air and the other one is moving through the barrier.
Günter Nimtz splits a microwave signal. The half that goes through the air travels at the speed of light and is displayed on an oscilloscope. The half that hits the barrier should go nowhere, but that's not what seems to happen.
This is an oscilloscope where you see the signal, and then we can see which one is faster.
The two humps on the screen are not in the same place, because one signal got there faster than the other, and the faster one tunneled through the barrier.
Only a very small part comes to the other side. But it comes, and this part comes at a velocity which is much faster than the velocity of light.
Nimtz believes that the faster signal uses a strange effect called quantum tunneling to get past the barrier. Tunneling depends on the fact that down at the quantum level, where particles are a lot smaller than atoms, the world is a totally random place. When a particle like a photon is here, it also has a small but very real chance of being here, or here, or here at the other end of the barrier. What Nimtz and his team did was to pick up the photons that appeared at the far end, and then to measure how fast they got there.
Also wie weit man runterkommt.
Ja, du brauchst jetzt nicht ernst zu werden.
I'm amused about this. We did this for fun. And when we figured out that it's faster than the velocity of light, we did not think about its importance.
The leader in this field, Raymond Chow, has misgivings about Nimtz's interpretations, but even he agrees with part of what Nimtz is saying.
In our experiments, we have measured that a single photon can tunnel across a tunnel barrier at 1.7 times the speed of light.
Chow agrees that quantum mechanical tunneling allows occasional random photons to break the light speed limit. What upsets him, and the rest of the physics world, is that Nimtz claims to have used it to send information faster than light. That really is taboo.
To have a genuine signal, you really have to control the signal. But in quantum mechanical tunneling, it's a completely random process. Fundamentally, we cannot send information with this tunneling particle.
Yeah, some colleagues were claiming that you cannot send information, and then we started to transmit Mozart 40, and this is, for instance, the original tape. That's what we sent at a speed of 4.7 times the velocity of light and a distance of about 14 centimeters. Whether you can recognize Mozart 40 or not.
Despite the random nature of the process, Mozart seems to have got through.
The essential question is, what is a signal, or what constitutes information? Has he really sent a signal in the sense of information faster than the speed of light? This is where Professor Nimtz and I part company, because we don't really have a rigorous definition of what is information at the quantum level.
Maybe that this is not information for American colleague, but for a German or a British colleague, I think Mozart 40 has some information in it.
This leads to an interesting thought experiment, a Gedanken experiment in German. What if you could tunnel a message to the other side of the universe? Going faster than light, the message would seem to go backwards in time.
I came across a nice Gedanken experiment. There's a signal going to a far star, which is information that you were born. And 20 years later, tunnel the signal at your age of 20 years, and this will arrive before the signal comes to the star that you were born.